Comenzamos. Luis Aguirre Santos es ingeniero en control y computación por la Facultad de Ingeniería Mecánica y Eléctrica de la Universidad Autónoma de Nuevo León. Actualmente es Territory Account Manager para la infraestructura eléctrica en la región norte de México. Ha desempeñado, además del cargo de gerente de canales eléctricos, cuenta con más de 20 años de experiencia dentro de Panduit y en la atención de la industria eléctrica como de telecomunicaciones, tanto para usuarios finales como integradores y distribuidores. Robert Krisel es un ingeniero mecánico con más de 27 años de experiencia en Panduit, graduado con honores de la Universidad de Illinois. Ha dedicado su carrera al desarrollo de productos, con 15 patentes y más de 200 millones en ingresos generados. Con experiencia en roles de ingeniería, gestión de productos y desarrollo de negocios, actualmente se desempeña como director de desarrollo de negocios eléctrico en Panduit, donde continúa siendo un recurso invaluable y un líder en su campo, impulsando la innovación y el éxito de la empresa. Sin más, damos inicio a nuestra sesión del día de hoy.
I'm Bob Krisel, Director of Product Management and Engineering for Panduit's Industrial and Electrical Infrastructure. Today, I'd like to talk to you about Panduit's cable cleat solution. I always like to start presentations by catching your attention on some of the opportunity that stands in front of us. Panduit and our partner ecosystem have a really great growth opportunity with cable cleats. What that looks like to us, in 2022, Panduit grew more than 100% in the cable cleat line. Year to date in 2023, we're growing by more than 65%. A lot of that growth is being driven by large, global, multinational companies that have started to specify our solutions. As those specs and standards multiply across the globe, there's great opportunity for all of us to grow our business. So there are 5 key objectives that I'd really like you to take away from the discussion today. First, what is a cable cleat? Second, why do people specify cable cleats and what do they do? Third, what is Panduit's cable cleat solution and how does it differentiate it from others on the market? We want to be able to help you select the correct cleats for yourself or your customers, and we have a multitude of tools to help you do so. So let's start. What is a cable cleat? A cable cleat is defined by a cable management component leveraged across the length of a cable bundle, secured at various locations. There's actually an international standard, IEC 61914, that's regarded as a global standard for cable cleats. It defines a lot of performance characteristics for the products. It establishes whether the product is going to be used indoors, outdoors, how it should be tested, and it includes a very specific request or requirement at the end, which is the performance of the product and its resistance to electromechanical forces that happen during a short circuit event. These forces are tremendous and can result in a lot of damage to people and property if not managed correctly. This is really what sets apart a cable cleat from any standard cable management component. Now, despite the IEC 61914 being an international standard, it's not always communicated directly into local and regional electric codes. They may reference a requirement for the product to support a short circuit event, but they don't explicitly call out how they should be tested or the performance characteristics that are required. So as a result, Panduit spends a lot of time working with standards bodies to improve the standards as written and improve the testing requirements needed to meet the short circuit applications that a lot of our customers are actually demanding. So now I'd like to talk a little bit more about a short circuit event itself and the implication that it has on the products in the market. Short circuit events are traditionally caused by a breakdown of the electrical cable itself, the wire insulation. And this could be a cause from chemical, thermal, maybe even manufacturing defects. But at the end of the day, the vast majority of failures of insulation jacket happen because of mechanical causes. This could be damage during packaging, damage during shipping, damage during deployment of the cable into a facility. Regardless of the cause, anytime the insulation is damaged, you open yourself up for a short circuit event. So I've given a few images here to help highlight some real world examples of insulation damage that could result in a short circuit event. What does one of these short circuit events look like? As I mentioned, they're a pretty violent scenario, and similarly would like to show a video to highlight really what happens during a short circuit event. This is a slow motion film that lasts in real time about 10 milliseconds. It's been extended to 30 seconds so that you can see what actually happens during the event. And so as I hit play here, you'll see almost immediately the straps that were used to contain the wire explode, is I guess how I would phrase it. There's tremendous damage to the ladder rack. The cables are permanently deformed, and you actually see some arcing coming from the end of the cable assembly where it's actually secured with a strong cable cleat. I think it's a great way of highlighting the impact of a short circuit event, and certainly one of the challenges here is that these cable straps, the stainless steel ties that were used in this demonstration, were not designed to withstand a short circuit event. So how does Panduit address this problem? Panduit uses design software called ANSYS that allowed us to analyze and simulate various short circuit scenarios. We used that software to ensure that we could replicate failures in the field. And once we were confident that we could replicate the failures at the really close proximity to where real failures happen, we knew we could take and modify the variables and make adjustments to our design. We actually used that software to make improvements to our product, as well as to help customers define or determine the correct cleats to use in their application. So I'll talk a little bit more about that further on in the presentation. So Panduit's approach to this challenge is to build a theoretical model to simulate all of the variables that affect how a cable cleat is going to perform in the field. In fact, our simulation was so good we won awards from the software provider ANSYS for our ability to accurately predict when failures were going to occur in the field. We use that data to redesign and improve the design of our existing portfolio of products, and we also use it to help customers select the correct products for their applications, which can vary wildly in the field. I've got another video to show you which actually illustrates how a cable cleat is supposed to perform in the marketplace. In this instance, the straps were designed to withstand the short circuit event, and you'll see the difference. So still a very violent event, certainly, but you can see the straps did not fail. They contained the wires. The cabling actually has some permanent deformation, but did not break apart. The ladder rack is not destroyed, and there was a little bit of vibration that caused some materials to fall off of the shelf in the back. But this is really an example of how cleats are supposed to perform in the marketplace, and it is, again, what sets apart standard cable management solutions from a cable cleat solution. Now, cable cleats are used in a wide array of applications, from power generation at the front end of a wind farm, a oil gas turbine, a nuclear facility, for the power cables leaving that facility. But they're also used in the infrastructure on the outbound side and on the distribution, whether it's to the factory floor, used for rail infrastructure, or inside of a data center application, for instance. In all of these instances, it's really ideal for the sales team to be involved early in the process. Engage with the EPC, engineering, procurement, and construction company, or the electrical contractor who's doing the design work. And the reason for that is really twofold. One, it makes sure that you're aware of the opportunity. And two, it allows you to make sure that the customer is educated on what a cable cleat does, why they want to use them, and whether or not they're actually intending to have short circuit protection for their electrical system or not. So the basic sales process remains the same. Awareness. Are you aware of the process or of the project and opportunity? Does the customer know what they want out of their electrical system in the design? Are they educated and aware of how to select the correct cleats for their job? And if you're aligned with the customer on all of those inputs, you can start having even more robust discussions. So the basic steps of the design process really are awareness, starting with, are you aware of the customer doing a project, building or designing a product, working with them, making sure you're educated and they're educated on what their expectations and the design of the job are expected to do. Once you know and understand those, you can start having some pretty robust discussions around the details of the project. What is the power coming in? What is the cable that they're going to use? What is the ladder rack they're going to use? All of those are inputs that allow you to create options from Panduit's portfolio that would meet the customer demand. At the end of the day, cable cleats are specified products. The customer, the contractor, is going to identify it by brand, typically by SKU, because they need to know they've got the right product as designed to meet the requirements of their particular project and situation. Now, it does not mean that we can't win a project after the design and build have already started. There's a couple of examples that we have where contractors had designed and built in cable management components that did not have short circuit protection ratings, and we were able to educate them on the requirements and the performance expectations that their customer really had, and we're able to get them to convert and switch after the fact. Of course, that comes at a penalty that oftentimes the contractor then didn't specify or include the cost of the cleats in his quote. So again, it's ideal to be on the front end of the project. Likewise, we have experiences where customers had already been competitors had already been spec'd into a job, and Panduit was able to go in and provide other options with a lower total installed cost and able to convert customers in that fashion. So not ideal. In an ideal world, we're dealing with the electrical contractor or the EPC firm at the beginning of the project, but we can still win jobs after the design phase has begun. So let's talk a little bit more about what Panduit's actual solution is. So I do have an additional graphic here, which highlights the breadth of Panduit's product portfolio. I think I referenced earlier, Panduit has the widest breadth of products designed for short circuit protection in the marketplace. It includes a wide range of strap cleats, both band and buckle style, and metal ball locking ties, both of which use cushion sleeves that are cut to length and help protect the cables that they're being installed around. It includes a range of trefoil cleats and quadrifoil cleats, depending on the customer's applications. And it involves a full range of plastic polymer cleats and aluminum cleats that allow us to compete against broad competitors in the marketplace. We have a lot of accessories, so actually I'm going to use a sample here to describe. Cable cleats are secured to ladder racks in the field, and ladder racks come in various designs and configurations, and they tend to vary a lot by region and or country. So Panduit has a line of accessories that allow our cleats to be attached to most of the cable trays that we've seen in the marketplace. And lastly, we have a line of tooling, tools that help install the products quickly and efficiently in the field. So now we've talked a little bit about what cleats are, why people use them, what Panduit's portfolio is. I want to talk a little bit more about the tools available to help you win in the marketplace. So Panduit actually has a dedicated team of business development professionals that focus on the cable cleat line. They're solely dedicated to training and educating our salespeople, our technical systems engineers, and our distributor partners on the value of cleats. They collaborate with the marketing team and build content and collateral like white papers, videos. Some of the videos that I showed today actually come from that team and that group, and some of the testing that they do in the marketplace. They're also available for you as part of the broad Panduit ecosystem to reach out and gain from their subject matter expertise. This team includes a manager and an individual business development manager in the European theater, as well as a business development manager in the North America theater. They've built a combined inbox, which is cleats@panduit.com or cleat@panduit.com. Now, as you get engaged with a customer, you're going to have to get pretty deep on the technical requirements. And so what that looks like is understanding the power going into the system. You're going to need to know what the peak fault current is of the electrical system. And depending on who you're speaking to, they may not know that. They may know what the RMS, the root mean square of the system is, and if they don't know that, they may know what the interruption current is for the circuit breakers used in the system. One of those inputs is really critical in order for us to do calculations and understand really the retention force required for the short circuit event. Once you know the power going into the system, there's an additional set of questions that you're going to need to learn and understand. It includes what the cable diameters are, what type of cable is being used, the insulation jacket and thickness. You're going to need to know whether it's an indoor or an outdoor application, whether it's exposed to UV or chemicals or harsh temperature extremes. And then you're going to need to know the cable rack and the cable tray that the product's being installed in. Really all of those inputs are needed in order to make a recommendation. Panduit has a tool called the Cleat Calculator that's available at panduit.com. And as you're engaged with a customer, you can collect all these inputs, load them into the tool, and you'll get an output which says which are the correct or what are the various Panduit products that you can use in that particular customer's application. Now we know not all of our salespeople are product experts. You may not be electrical experts, and you may not be super comfortable asking all of these questions for your customers, particularly the first time you're doing it. Again, feel free to reach out to the Cleat team at cleat.panduit.com, and you'll be able to get and leverage them. They'll either train or educate you so you're comfortable to have the discussion with the customer, or they'll join in on the actual dialogue with the customer themselves so that you're able to collect the information appropriately. So now that you understand what a Cleat is, why organizations use them, what Panduit's offering is, some of the sales tools that we have, I want to reiterate why Panduit is excited about cable cleats as a product opportunity. As I mentioned at the beginning of the discussion here, cable cleats are a rapidly growing market segment, and the adoption is starting to accelerate as more and more global multinational companies start to build cable cleats into their specifications. Panduit's well positioned to be the global leader in this space as a manufacturer with a large sales and distribution footprint. A recent example that's probably most relevant to this audience is actually one out of the US from a company called Quality Technical Services. This is a data center application, and Panduit was engaged early with the EPC, who in this case was a company called Rosendin. It's a great example of being involved early because we knew what the power requirements were for the data center, we knew what cabling they were going to use, and we knew what ladder rack they were going to use. That allowed us to provide recommendations, good, better, and best, to the customer, and allowed them to make a decision about what style of cleats made the most sense for them in their application. They ended up going with a strap style cleat with our cushion sleeves and a manual installation tool. And the end result for Panduit, we're on the specification. We actually got physical orders in 2002 and started shipping product towards the end of 2002. And that was for one data center hall, and the total value for Panduit and our distribution partner was approximately $400,000. So pretty sizable dollar opportunity where we're in on a specification and really have a leg up for this customer the next time they do a data center build. So that's just one example. It highlights a data center example where we got in early, we're able to specify the products and win the project for Panduit. I'd like to finish the presentation once more reminding the group that there's a large number of global data center customers that have already started to use our products in their data center applications. And hopefully you see a few of the names on here that you recognize and do business in your region or local areas. It's a great opportunity for you to look, see, and understand if they're doing any additional new builds in your region and territory. Start to engage with them, learn about what their power requirements are, and look for opportunities to spec Panduit cable cleats into their applications. So thank you for joining me today and learning more about Panduit's cable cleat solution and how we can help you continue to win in the marketplace.
Muchas gracias por acompañarlos a la presentación de Bob Krisel, y quisiera repasar algunos importantes de lo que nos estuvo mencionando Bob. Repasemos qué es una abrazadera para cable, o como le llamamos internamente, cable cleat. Según el estándar IEC 61914, un cable cleat o una abrazadera es un dispositivo provisto de un medio de fijación a una superficie de montaje que provee aseguramiento de los cables cuando se instala a intervalos a la corrida de los mismos, ¿no? Este estándar IEC 61914 tiene algún resumen de requerimientos, como las temperaturas de aplicación, la resistencia al impacto, la carga o retención lateral o axial de los mismos, la corrosión, la resistencia a los rayos ultravioleta, la resistencia a la propagación de flama, el marcaje del producto y la documentación adecuada, y principalmente la resistencia a fuerzas electromecánicas. ¿Qué quiere decir esto? Es la capacidad de soportar un evento de cortocircuito o dos eventos, asumiendo que los clics soportaron el primer evento. Y la capacidad de pasar una prueba de tensión soportada, que depende de uno o dos eventos de prueba previos. Esto es lo que nos dice el estándar IEC 61914. Pero ese estándar IEC, ¿cómo funciona en nuestro continente, tanto en Norteamérica o en Latinoamérica? Los estándares IEC tradicionalmente son considerados estándares internacionales. Y en Norteamérica, en Estados Unidos, Canadá y algunas partes de Latinoamérica como en México, se considera como un estándar europeo. Sucede al revés con los estándares UL y CSA, que son referenciados como estándares americanos a través de Europa. Esto nos da como resultado que Estados Unidos, Canadá y regiones de Latinoamérica no se rigen por la misma legislación u orientación técnica para los cable clips. ¿Qué es lo que Panduit hace al respecto? Nos acercamos a entidades como NEMA, CSA y UL para tratar de armonizar los estándares para los cable clips o abrazaderas y que vayan alineados a los requerimientos que tiene IEC 61914. Entonces, Panduit forma parte de estos comités para estas agencias de normatividad. ¿Por qué son necesarios los cable clips? Y vemos que el pico de fuerza electromagnética en un evento de cortocircuito ocurre a los 5 milisegundos en sistemas de 50 Hz o a 4 milisegundos en sistemas de 60 Hz. Un interruptor termomagnético de protección se activa a los 0.06 segundos o 0.1 segundo. ¿Qué quiere decir esto? Que cuando el interruptor se activa, la fuerza electromagnética ya actuó, ya dañó nuestra infraestructura o ya intentó separar los cables. Y en esto, como comentaba Bob, que es un evento violento, pues puede generar muchos daños, ¿no? Entonces aquí el voltaje ya es irrelevante. El tiempo que tienen que soportar activamente entre 5 milisegundos a 0.06 segundos, pues son alrededor de 100 milisegundos, ¿no? Entonces, para eso es importante tener nuestras abrazaderas para cables. Otro punto a repasar, que sería cómo especificar los cable clips o qué información necesitamos, ¿no? Uno sería la corriente máxima de falla. Si la corriente máxima de falla es desconocida, calcular la corriente RMS de un sistema. Si ambos valores son desconocidos, utilizamos el valor de interrupción de cortocircuito de nuestra pastilla o de nuestro interruptor termomagnético, ¿no? Necesitamos información del cable, qué atributos tiene, qué clasificación, cuál es su diámetro, tamaño, peso. Otra es de la instalación, cómo vamos a formar los lazos, va a ser una corrida larga, vertical, horizontal, de 3, de 2, de 1, etcétera, ¿no? ¿A qué escalerilla lo vamos a sujetar? ¿Cuál es el tipo de peldaño, geometría, qué dimensiones, qué espaciamiento vamos a requerir y si la escalerilla tiene o no ranuras? Y algunos parámetros ambientales, como si está en exteriores, interiores, si el ambiente es corrosivo, si va enterrado o por encima, ¿no? Y muy importante es consultar con el equipo de Panduit para validar esta información y hacer la mejor selección posible de producto. Por último, quisiera repasar las herramientas que tiene Panduit. Utilizamos el navegador. Aquí les pusimos el código QR que pueden escanear actualmente. Y principalmente esta herramienta nos va a pedir 3 valores para recomendar los cable clips, que es cuál es la forma del mazo que vamos a utilizar, ya sea de 3, de 1 o de varios o de multicore, de varios o de 4. ¿Cuál es el diámetro en milímetro de nuestros cables? ¿Cuál es la corriente de cortocircuito? Un pico de cortocircuito. Y con esto terminaremos nuestra presentación. Mónica, por favor, nos acompañas con las preguntas de la audiencia y nuestra dinámica.
Muchísimas gracias, Luis, por tu participación el día de hoy. Invitarles a todos, bueno, primero que nada, bienvenidos a otro webinar más. Invitarles que si tienen alguna duda o comentario, nos los puedan poner en la sección del chat para poderlo contestar en las secciones asignadas. Vamos por nuestra primer pregunta. Muchísima suerte a todos. ¿Cuál es el estándar internacional para las abrazaderas para cables? Vamos a ver. ¿Hay alguna de las posibles respuestas? Y bueno, la respuesta correcta, pues precisamente era la roja. Así que no sé si aquí Luis quieras agregar algo. Digo, la mayoría lo tuvo correcto, pero no sé si quieras reforzar algo aquí.
No, muchas gracias. Bueno, la mayoría tuvieron la respuesta correcta que estuvimos repasando durante la presentación. Los otros dos estándares en FPA 70E se refiere un poquito más acerca de cuestiones para desconexiones de sistemas eléctricos. Y la UL 486 es más sobre terminales y otro tipo de accesorios de conexión en sistemas eléctricos. Pero sí, el IS 61914 es el adecuado.
Así que vamos por nuestra segunda pregunta. ¿Qué herramienta tiene Panduit para ayudar con las especificaciones de abrazaderas de cables? Ahí tenemos algunas de las posibles respuestas. Vamos a ver. Quedan pocos segundos. Y bueno, la mayoría igual tuvo la respuesta correcta, que es la azul. No sé, aquí Luis, ¿quieres hacer una intervención?
Jóvenes, necesitan poner un poquito de atención. Era muy sencilla la pregunta. Fue la última slide que repasamos donde hablábamos del Click Calculator, que es una aplicación vía una página web donde nos ayuda a seleccionar en base a la información que le proveamos cuál es la mejor opción que tenemos en la parte de abrazaderas para cable, ¿no? Las otras dos herramientas, el EasyMark Plus es para nuestras etiquetas, impresoras y sistemas de identificación. Y la parte de Rapid ID involucra más ya la parte de patch cores y memorias técnicas que podamos realizar, ¿no? Click Calculator es la respuesta correcta.
Así que vamos con esta tercera pregunta. ¿Qué eventos pueden dañar el aislamiento de un cable? Vamos a ver. Quedan pocos segundos. Y nuestra respuesta correcta era todas las anteriores, que ahora sí la gran mayoría la tuvo correctamente. ¿Quieres aportar aquí algo, Luis?
Ahora sí que en esta pregunta no hay una respuesta incorrecta. Más bien lo que hay son respuestas incompletas, que serían los que seleccionaron la parte de eventos químicos y empaque, ¿no? Generalmente, digo, hay muchas opciones por las cuales un cable puede ser dañado y realmente esta parte involucraba todas las respuestas, ¿no? Todas las anteriores sería la respuesta correcta.
Y ahora sí, esta es nuestra cuarta pregunta. ¿Cuáles son algunas de las aplicaciones para las abrazaderas de cables? Igual está muy fácil, mucha suerte. Vamos a ver, quedan algunos segundos. Y bueno, la respuesta era todas las anteriores. Igual, ¿quieres agregar aquí algo, Luis?
Así es como lo comentaba en la pregunta anterior. No hay respuestas equivocadas. Realmente en la generación de energía son productos muy empleados, pero ha ido incrementando la opción de dónde se utilizan los abrazaderos de cable o cable clips, ¿no? Realmente en todas las industrias que mencionamos aquí, como les decía, no hay respuesta incorrecta, realmente son respuestas a la mitad o incompletas, ¿no? Porque realmente todas las anteriores y últimamente cada vez vemos más en la alimentación eléctrica de centros de datos el requerimiento de tener este tipo de abrazaderas, ¿no? Para evitar daños en la infraestructura alrededor de un centro de datos.
También recordarles que esta sesión se les va a poder compartir, se va a subir también al sitio de Panduit en la sección de eventos para que lo puedan volver a consultar o si alguien está interesado, pues les puedan compartir esta presentación. Hasta el momento no tenemos preguntas, pero no sé, Luis, si quieres agregar algo que creas que es como de valor.
No, no, digo, cosas que les pudiera comentar a nuestra audiencia es, ustedes están muy involucrados en la parte de la parte de centros de datos o conectividad de redes. Bueno, todos estos proyectos requieren alimentación eléctrica, ¿no? Y dependiendo de las dimensiones de cada proyecto, vamos a ver la capacidad o la necesidad de tener alimentación eléctrica de mayor capacidad. Y aquí es donde podemos ver oportunidades para nuestras abrazaderas de cable, ¿no? Para mantener una infraestructura segura en base a lo que hemos platicado durante la presentación.
Pero nos preguntaban que si había algún folleto de estos productos. Y sí, de hecho en el chat estamos compartiendo algunos links que les pueden ayudar, tanto del sitio de Abrazaderas como el folleto de Abrazaderas, ¿no? Y de las aplicaciones que tenemos, y ahí lo pueden consultar para que puedan obtener más información.
Sí, también en el chat se puso el link al Click Calculator, que ahí viene precisamente, no solamente viene la forma de calcular, vienen sugerencias y vienen links a los boletines de producto de las abrazaderas para cable de cortocircuito.
También
Igualmente está ahí mi correo por si gustan mandarme algo de información, alguna pregunta adicional que tengan.
sí, ahí como comentó Luis, ahí acabamos de poner en el chat igual su correo para que le puedan escribir. Adicional, igual me gustaría, pues también compartimos un link de CREM. Recuerden que esto es muy importante, que si están inscritos, pues pueden descargar recursos para promover el producto. Así que también los invitamos a que puedan acceder a este link. Pues creo que no hay preguntas. Agradecerte nuevamente, Luis, por conectarte, por brindar información de valor. Así que gracias por acompañarnos. Y no sé si quieras cerrar con algo, Luis.
No, no, muchas gracias a todos por acompañarnos y espero recibir sus comentarios o preguntas o algo de información que requieran. Muchas gracias. Buen día.
Gracias, buen día.